In this video, I'm going to solve an initial value problem using Laplace transform. So the equation is y double prime plus 3y prime plus 2y equals t times unit step function of t minus 3 with the initial conditions y of 0 equals 0 and y prime of 0 equals 1. So the first step is to apply Laplace transform to both sides. So we get Laplace transform of y double prime of t of s, right, the correct notation, plus 3 Laplace transform of y prime of t of s. I actually moved the 3 outside because Laplace transform is a linear function, plus 2 Laplace transform of y of t producing a function of s equals Laplace transform of t times u of t minus 3. Now I wrote a few formulas and I computed a few of the things that we need to know. So one of the formula is Laplace transform of the first derivative, which is going to show up here. So I wanted to write that out. I also wrote the formula for the second derivative, which we'll need here. And then we have to find the Laplace transform of this term. So first of all, I wrote what the unit step function is, shifted 3 units to the right. So u of t minus 3, it's 0 up to 3 and then 1 from 3 on. T times u of t minus 3, it's multiplying u by t, we get 0 for t less than 3 and t for t greater than 3. And we have to find Laplace transform. So you can pause the video, try and find Laplace transform of your own, and I actually ended up with this expression. So now, going back to our problem, this is what we get. So from here, we have Laplace transform of y double prime is going to be s squared, and I'm going to write Laplace transform of f of t of s. I'm just going to write it capital F of s like that for shorter notation. So I have s squared f of s minus s times f of 0, or y of 0, it's 0, so that term disappears, and then minus f prime of 0, so minus 1. And I just computed the very first term, this one. Now let's go to the next one, plus 3 times, and now Laplace transform of the first derivative, which is this one, it's s f of s, and then minus f of 0, or y of 0, which in our case is 0, so I didn't need to put parentheses actually, and then plus 2 f of s, and that's the right hand side, equals, the left hand side equals the right hand side, which we computed it, 3 over s, so it's not 5, it's s, e to negative 3s minus e to negative 3s over s squared. And so this is the equation that we want to solve. I'm going to write it down here in a second. So let's solve it. I am going to factor out f of s from all these terms here, and I'm going to obtain s squared plus 3s plus 2. And then I'm going to move this 1 on the other side. So it's going to be, and I want to have the same denominator, so it's going to be 3s e to negative 3s minus e to negative 3s plus s squared, everything over s squared. So f of s is actually 3s e to negative 3s minus e to negative 3s plus s squared, everything over s squared times s squared plus 3s plus 2. So to find f of t, we have to actually, or in our case, y. I actually changed my letters. Well, it should have been y of s everywhere, but let's just make that substitution. Y of t is equal to f of t, so that will make sense how I ended up with f everywhere. So to calculate f of t, or in other words y of t that we wanted to find, I'm going to do inverse Laplace transform of f of s, so of t, so it's going to be inverse Laplace transform of 3s e to negative 3s over s squared times s squared plus 3s plus 2. I'm going to separate it in 3 of them, minus inverse Laplace transform of e to negative 3s over s squared times s squared plus 3s plus 2, plus inverse Laplace transform of s squared over s squared times s squared plus 3s plus 2. So we don't need all these, right? I can cancel this s with this one and this s squared, and I get 1 at the top here. So let's calculate one of them. I have 3 things, so 1, 2, 3. I'm going to do the first one. 2, 3. I counted them from right to left. So inverse Laplace transform of 1 over s squared plus 3s plus 2. How do we do that? Well, I'm going to use partial fractions. So that's why you learn partial fractions in Calc 2. This is s plus 1 times s plus 2. And so I get a over s plus 1 plus b over s plus 2 multiplied by s plus 1 times s plus 2, and end up with 1 equals a times s plus 2 plus b times s plus 1. So if we set s equal negative 2, we get 1 equals negative b, or b equals negative 1. If s equals negative 1, I just take the zeros of these parentheses for easier computations. I get 1a, so a equals 1, which means this can be written inverse Laplace transform of 1 over s plus 1 minus inverse Laplace transform of 1 over s plus 2, which means if you look in the table from the definition of Laplace, this is e to negative t, and the second one is e to negative 2t. So we calculated the first inverse Laplace transform that we wanted. Maybe I should color coded them differently. Let's make the second one green, and let's make the third one purple. Oh, actually, it's gonna end up being blue. Okay, so let's do the second one. Inverse Laplace transform of 1 over s squared times s squared plus 3s plus 2 times e to negative 3s. So we are going to calculate just this piece alone, s squared times s squared plus 3s plus 2, by doing a over s plus b over s squared plus c over, well, this one can be s plus 1, x plus 2. So c over s plus 1 plus d over s plus 2. And because I don't have enough time to actually pose the whole thing, I'm going to, please pause here, try to do your own, and I'm going to solve it and unpause when I'm done finding a, b, c, d. So I did all the work, and I found that a equals negative 19 over 36, b equals a half, c equals 17 over 36, and d equals negative 1/4. Maybe you want to double check that is correct. Now, in order to calculate, let's not forget this is what we want to calculate. In order to calculate that, there is another formula that we need to use. The inverse Laplace transform of e to negative sa f of s is equal to f of t minus a times u of t minus a. So in our case, f of s was calculated here. This would be our f of s. And then we have e to negative sa, so basically a equals 3. So then our functions are going to be each of these individually calculated. So a is negative 19 over 36. And then I have inverse Laplace transform of 1 over s is 1. So then we have 1, so times 1 times u of t minus a, so t minus 3. And we just calculated the a over s. Now plus b over s squared. So we have plus a half And then inverse Laplace transform of 1 over s squared is t. So it's going to be t minus 3 times u of t minus 3. Now c, so plus 17 over 36, and inverse Laplace transform of s plus 1 is e to negative t. So it's going to be to negative t minus 3 e to, sorry, not e, u of t minus 3, and then plus d, which is negative 1/4, so minus 1/4 e to negative, it should be negative 2t, so it's going to be minus 2 because we have to shift it, so t minus 3 and then u times t minus 3. So this is the answer for the second part, which I highlighted in green. So I'm gonna highlight this answer in green because that's my second problem. So this is the first one and this is the second one. And now let's take a look at the third one. So I took just the piece, this piece without e to negative 3s, and I calculated each of the terms. Again, I used partial fractions, so then we obtain this inverse Laplace transform of a is 3 over 2, inverse Laplace transform of 1 over s is 1, so it's times u. A is again 3, so you have t minus 3, and then the second part, the b, minus 3 e to negative t minus 3 u of t minus 3, and then c is 3 over 2, so plus 3 over 2 e to negative 2 times t minus 3 u of t minus 3. This is our third part, which I try to do in purple, so this would be the third part. And so together 1, 2 and 3, I don't have, 1, 2 and 3 are going to be the solution. So what you can do is actually add any like terms if you have, like maybe for example these two will be like terms. I also think that these two would be like terms, so they can be added up, but this is pretty much what you need to do. So to wrap it up, I actually put them together. So the final solution, y of t, again, I kind of played a little bit with f of t and y of t, but they meant exactly the same thing. So y of t is given of this. This is the final answer by adding like terms and everything. So I do hope it helps.